Here's a glimpse of the custom graphical user interface I'm building for my FEM solver, designed specifically for metal forming simulations. Built in C++ using ImGui, OpenCascade, Gmsh, VTK, and Python scripting. Most existing FEM tools are heavy, inflexible, or hard to customize. I wanted a fast, modern, scriptable graphical user interfaces to streamline metal forming simulations. This graphical user interface started as a lightweight side tool for my SPH solver. Later, I expanded it to support my explicit FEM solver, and now I'm redesigning it to work with my updated Lagrangian implicit solver for forcing problems. It's evolved alongside my simulation research. Mesh generation is powered by OpenCascade and Gmsh, and visualization is done with VTK. Thanks to SWIG, the GUI supports Python scripting to help build models programmatically. Right now, the GUI supports mesh creation and boundary condition setup. Soon the full implicit solver will integrate here. The heart of this project is my updated Lagrangian implicit and explicit FEM solvers, tailored for metal forming, like ring compression and backward extrusion. While the solver core and some advanced GUI features are part of a premium package, the open components will remain available for experimentation and learning. Let's look briefly at how the code works behind the scenes. The entry point starts with a Python initializer and a singleton app class, meaning only one instance exists, with a global point of access. This app object manages the core application state. The editor class handles user interaction and calls the VTK viewer, a great library for rendering. Inside the GLFW main loop, the app checks if a new graphic mesh has been created. This is the visual representation of the real FEM mesh. The app class manages the graphic mesh creation from the active FEM model, following the logic of tools like Abacus or LS-Prepost. Models are structured into parts. The graphic mesh class uses VTK polydata to manage what you see on screen, with flags linked to VTK actors. There's also a mockup of a Python console built using ImGui. It sends commands to a SWIG-wrapped C++ backend. With this setup, we can generate a mesh, assign it to a part, and add that part to the active model, and update the view, all from Python, like in, for example, ParaView. This opens the door to automation and macros. If you're into FEM, SPH, CFD, remeshing, or just enjoy watching solids get squished by clever math, you're in the right place. I dive into open source solvers, CPU acceleration, and how these methods actually work under the hood. So hit subscribe, or better, hop on the mailing list at opensourcemac.com. No spam, just good stuff. And if you want to support or ask deeper questions, there's always my Patreon. Thanks for watching and happy coding!